I've got a question for you this week. How many houses do you think you've been in? Well, for better or worse, AI says 200 to 500. It's a big number. Those buildings have to all be safe and well designed for their environment. Not excessive, so people are able to make the purchase, but not skimping on material or design either. Banks hold a tremendous value to a wooden box that was certified as safe by an engineer. Sure, there's some more detail there, but I think you get my idea. Houses are important. Let's learn how they're done correctly.
The Structural Engineering Podcast.
My name is Sean Buckner. I own a structural engineering firm based in Southampton, New York, mainly focused on high-end residential construction, single-family homes, beachfront, and whatnot.
This episode is brought to you by CalcBook.
If you've ever spent hours digging through spreadsheets for errors or used software that spits out results but hides the math, you've probably thought, there's got to be a better way.
CalcBook gives structural engineers transparent, line-by-line calculations in a clean, user-friendly interface, so you can trust your results and work more efficiently.
Listeners of the Structural Engineering Podcast get 50% off their first 3 months at calcbook.com with promo code SEPOD. That's SEPOD, all capital, all letters. We'll put it in the show notes.
CalcBook, calculations done right.
Well, Sean, we're excited to talk to you. I looked up this number earlier that 90% of buildings in the U.S. are homes. And I feel like that puts a good benchmark as, the daydream of building a high rise. Most buildings are homes, and to do this correctly means a lot. And so I'm really excited to talk about some of the fancy homes that you've done, like custom, and, not every home is a box with straight sheer walls and no windows. They can get pretty complicated. So we're excited to hear how you've looked at this and how you interact with clients, architect. So we got a lot of questions for you. The first one, I guess, setting the stage maybe. Biggest difference between residential and commercial structural work for those, for the audience that has done mostly commercial, how do you see the difference between these?
I think the biggest difference is, the scale of the project. Residential projects, I've worked on projects that are 20,000 square foot mansions that, is a humongous home, but still is less of a elephant to tackle than, a skyscraper or something like that. So the team sizes are a bit smaller. You're not going to be, in one of these, 500 person offices, and you're going to be designated to the glazing while someone else is worried about the columns and someone's on the Q decking. Typically, most houses, even in the 7,000 to 10,000 square foot range, which are, very nice high-end houses, can be handled really by one structural engineer, maybe with someone assisting with some of the drafting or something like that. But even on the high-end jobs, you're kind of working maybe with one or two other engineers. So you really tackle the entire project. You start at the roof, do all the framing yourself, whether you're in an office that does geotechnical engineering or doesn't. You trace all the loads down, and then you either design the foundations and the piles like we do in my office. So you kind of don't get pigeonholed into one specific aspect of the construction. You really see the job in totality.
I'm curious too, if we even step back a little bit further, what drove you to starting your own engineering firm?
I guess taking an even further step back, what drove me to residential? I grew up closer to New York City, which is a lot of skyscrapers, a lot of bridges. In university at the University of Buffalo, they focused a lot on seismic design. Them and Berkeley have two of the bigger shake tables in all of the college academics. So inherently, you would think I went into the city and started doing that kind of stuff. My dad actually started a high-end swimming pool company out in Southampton when I was very young. Grew up, worked for them for multiple summers, worked in general construction out on the East End, and always saw these crazy modern houses, things you don't see. And I grew up in Nassau County. It's a lot of your 3-bedroom ranches, conventional construction. So I was kind of plumbing the pool under some of these crazy cantilevers and things like that, and asking a lot of the job foremans, who's designing these. Sometimes it was local architects, but a lot of times it was city engineers or an engineer from Connecticut or something like that. There wasn't many local guys. I started up with someone who Also started a company about 8 years ago, worked for them for, my career. And then actually about a year ago, started my own firm. So it's been about a year, staying busy,
Yeah.
a lot of good clientele that I worked with and whatnot. So, but yeah, that was kind of the path into residential. And then what
Okay.
drove me to start my own company was, just I think the amount of responsibility I would put on myself working in with my old firm, I it's smaller, like I kind of just said. When you're on a project, you're kind of running that project and whatnot. As I started to develop those relationships and, with contractors, with architects, it kind of was just the natural progression, I would say.
Okay. And then I grew up on the West Coast, haven't spent a lot of time on the East Coast. When you say the Hamptons, I have this picture in my mind of parties and big, big houses. Is that what we're talking about? Or what we're going
That
to
is
talk
what
about
we were
today?
talking about.
Okay.
Unfortunately, as the structural engineer, I rarely get invited to those parties. But we are talking about a lot of those. I mean, some of the big name streets or lanes are Dune Road, Further Lane, Meadow Lane. That's where, you have some of these 20,000 square foot houses. You have houses on Further Lane that have 3-hole golf courses and things like that across the street. Those are the mega mansions. So that is,
Okay.
and that's still the 5% of, 5 to 10% of jobs that we work on. There's a lot of houses in East Hampton and Southampton that are, still, I mean, a 7 to 10,000 square foot house is nothing to balk at. But yeah, we're in that game.
Okay. Yeah. I'm just not familiar with the West Coast as much or the East Coast as much. So I just wanted to kind of set that. Um, so how does the engineer, architect, and owner relationship usually work with these types of houses? When you're starting off, who's in the room, who's making the call, and kind of what does that all look like?
Yeah, so basically I would say the architect is kind of the point guard of the team. They're normally the first person brought on by the client, however they get referred, if they've worked with them before, this, that. But the client goes to the architect and they really start from scratch. What the dream is, are they looking for a modern home, a classic home, all that kind of stuff. That is a ton of legwork. So from there, and I think to Max's point, with going back to that 90% of houses, 90% of structures in the US are residential homes. A ton of those, a vast majority are, your 3-bedroom ranches and things like that that are more conventional construction. And an architect can really design them through the International Residential Code. If you have a 15-foot span, 16-foot span, you can use 2x10s or 2x12s. There's prescriptive methods and prescriptive tables for hold downs and things like that for more standard geometry and standard homes. So I say that to say the architect is the first person brought on to basically any residential project because they're starting to study the zoning, the desires of the homeowner, what's feasible, things like that, and coming up with the art, the aesthetic with the functionality, the programming, all of that. So on some of these higher end jobs, they'll start to develop their set. And then once they get to a point where, the construction's starting to get atypical and they're not, so comfortable designing all of the framing members, if it's beachfront and they're saying maybe we need piles here, I'm not really sure. That's where they bring on a structural engineer. And even for some of the, smaller 3,000, 4,000 square foot houses, which again, decent house, but maybe doesn't need a full structural engineer for, a lot of the times I have architects who are comfortable enough with the prescriptive methods and then might reach out to me and say, hey, Sean, I need 2 or 3 beams designed because this is, we want to do an 18-foot beam separating the kitchen and the living room. That's kind of the relationship. They're kind of like the project lead and then hire us or subcontract us as needed for a full structural set or helping them out with elements in a smaller house.
I'm curious, and so I don't really know, but I have a feeling a lot of people that only work in commercial might have a guess. Will you be consulted just for a few beams, like you mentioned, so you do not give a full drawing package? It is just, here's what you consulted on, your drawings relate to that only, and it is part of the architectural package?
Typically, that's the way it works because, I'm not going to submit a set of floor plans with 3 beams called out,
Yeah.
So a lot of the times, and it is typically architects who, already trust me, use me on, or use an engineer on, higher end things. And maybe they got a smaller project and they reach out. Typically, I'll size it. I don't need to produce the drawings. I don't need to stamp it. I just give them the recommendations and, they trust that I'm doing the legwork on my end. So they wrap it up into their set and then, submit their package.
Interesting. Another silly question here, but like the IRC, I haven't worked in a long time. what are the limitations that you have there? Obviously the standard house that's 50 by 50 square with floors that span 12 feet is kind of, you can just pull out of that. But beyond span regions that are reasonable and shear walls that are quite a bit of the building, like when is that cutoff that you need an engineer for a house?
Yeah, I mean, I would say the two biggest things I would say, other than like you said, spans. When you're trying to push a 22-foot span, obviously that's above just a 2 by 12,
Yeah.
and we'll use engineered lumber for that and things like that. The two biggest things is the glazing. Everyone wants when you're beachfront, you don't want any walls interrupting your view. So the IRC doesn't give prescriptive methods when 50% of the walls are glass. A lot of times you either need to jump up to Simpson strong walls, which are good solutions when you have 18 to 24 inch segments between the glazing, or if it's really nothing and they're trying to just do as small mullions as possible, jumping up to steel moment frames, welding the flanges and whatnot, or cross braces. But cross braces are less common, obviously very prevalent in commercial, but in residential you normally can get a shear wall to work, depending on your full design and everything like that. So if you have the wall availability, typically I feel like there's a solution using double-sided plywood, heavier hold downs, things like that. So when you need to jump up to steel, frames, you don't have the wall space to do a cross brace. They want to put a nice, big piece of glass there.
That makes sense.
Okay.
I certainly love the aesthetic of a cross brace, but that might be why I jumped from arch to engineering. So
Yeah,
good fit.
so do I.
Okay. Yeah,
I rarely get to see, we're on there for inspections up front and whatnot, which I get to see all my steel beams and everything like that, but they're trying to close it up and hide it from me as soon as possible.
Like, get out of here so we can just drive all
Yeah.
of this.
The other thing that really jumps it up is a lot of these cantilevers that people are trying to achieve.
Yeah.
Modern homes are very much the wave. I mean, I see a ton of very elegant, I call them West Hampton, more of the classical houses with the gambrels and things like that. But a lot of houses do want to do, a lot of glass, modern, second floor cantilever. So the IRC is not going to give you, solutions for things such as that.
Yeah. When a designer comes to you and, they start with, I want the open concept. You sort of mentioned this, like braces that are available that are a little more slender. What are the first questions you ask as you get into the layout of this building?
So something that I've really tried to implement while starting my own firm in the last year, which a lot of my clients have really appreciated, is trying to really, it's the Hamptons, Zach, like you said, it's these high-end homes, it's custom, rather than just kind of like plugging through the structural design. I really like to, in my first go around, I really try to frame the entire house, roof to, first floor, without sizing anything, but laying out the roof geometry, seeing where the load paths are going to be, what are the main lines of bearing and things like that, and then taking a pause and really trying to point out, it might be only one thing sticks out to me, it might be 5 things that stick out to me, where it's, hey, can you shift this wall 11 inches so we can catch this steel column rather than having to do another, and I mean, especially that the bigger the home, the more they're kind of dead set on their design, because it's a piece of art as much as it is, a house. So every minute detail, every inch, we even have conversations about 3/4 of an inch, 3/8 of an inch at times with ceiling pack outs and things like that. So sometimes it's, hey, Sean, thanks for the recommendation, but we want to stick with the plan as is, do what you got to do. But I think on a large majority of jobs, if it's shifting a wall 7 inches or, thickening it up, like I said, if they're showing, say, 13, 14 inches between glazing, and I do a quick calc, try to get a decent, idea of what the shear is going to be on my, rear wall. And I know if we get 3 18-inch strong walls that we can avoid, the steel moment frames, I try to do some quick calcs. And before I get too far, and then I have to say, oh, well, yeah, you need to have $230,000 of steel in this project. And they say, well, can we V this? And then I got to charge them more and this and that. Try to upfront give a couple ideas based on what I'm seeing of alignments and things like that, so that they might be able to pivot quickly, and then I can design the framing as needed without having to waste everyone's time for a couple, weeks or a month.
With being in the region that you are are we governed mostly by wind, seismic from a lateral standpoint? What kind of wind speeds are you dealing with, or seismic design categories?
Wind for sure.
Okay.
I think we're seismic category B, but we're dealing with 130 to 140 mile per hour winds. So a bit of a
Definitely
difference.
wind.
Yes.
Serious.
Yeah. So that definitely governs us. And then, a lot of the beachfront properties need to be exposure category D. We're dealing with generally houses that are governed by zoning codes to be 32 feet or less. So you're kind of fixed on that. But definitely wind, and then the open exposure becomes cranks things up a bit when you're on the water.
That makes sense. So I'm imagining we're in the Hamptons. You sit down with a lot of clients, probably architects, and they say, "Hey, I saw this online. Well, I want to do it this way, or I really like how this is." How do you handle those requests? And I imagine maybe you just brought up VEing, which blew my mind because I would have figured they just give you the whole checkbook and said, "Hey, go for it." But which is, I think, something all of us structural engineers just dream about with exposed
Yes.
brace frames. But how do you handle those requests and that maybe are unrealistic without totally shutting them down? To keep them excited.
Yeah, for sure. There are some clients who just hand you the checkbook and they say, I don't care. And there has been projects with some decent cantilevers where VE kind of comes up, and I say, if we add a column out there, we can probably reduce 80% of the steel. And they're like, no, that's not part of the VE process. Something else needs to be. And I'm like, all right, well, that's most of the money. But in terms of that, I always try to give some kind of solution. As an engineer, I feel that there always is some kind of solution. Whether the beam needs to become way larger than their cavity, or if we need to do some kind of split cantilevers by welding, the beams together and things like that. I normally will flag it and say, hey, this is going to be, a sticky point. Then if they say we want to stick with it, I'm like, all right, let's go with that. But I'll start to run the numbers, get some of the beam sizes. And a lot of times, if it's like an isolated area, I like to give them the option they want and then try to put together a partial plan on the side with, hey, if we add 1 or 2 columns, see where these beam sizes go, so that it's tangible. It's not just, oh, I think you could save a lot of money by doing the columns. And it's like, yeah, but how much? Seeing the 2 plans and seeing a W, 14 by 230 reduced down to a couple W 14 by, 50s, it's like, oh, okay, this is the scale we're talking about. So a lot of times I present both of those. I would say the election in the prior to bid and things like that are like, okay, that's awesome to know. Let's stick with the design as is, see where the prices come in, and then we have that in our back pocket as, a VE option. So it serves its purpose. A lot of the times the architects want to try to maintain their intent, so they stick with their plan. But I would say a number of those times kind of goes out to bid, and then we say, okay, which of the options do we want to pick up to save some money?
All right. So I just heard you call out a beam size that is probably bigger than most commercial engineers work with. Are you seriously working with beams that are over 200 pounds a foot?
That is, I would say, a handful of times I've spec'd beams over 200 pounds. I would say, what's today? Today's Tuesday. I would say on Thursday, I sent over very similar to what we were just talking about. It was pretty conventional, first floor, second floor. The roof was what the roof was. We had a main line of bearing right down the middle. It was a hallway on the first floor and the second floor. So we're picking up all the ceiling load, the second floor. And then now we have a open, I think it was like a 30-foot by 70-foot game room in the basement with a couple walls on the sides for a couple powder rooms and whatnot. But, I highlighted that to the architect. I said, I think this is going to be tricky when I start tracing all the load down there. And as I started to run the calcs with the spans, and then also realizing, hold on, we have a lot of 50% of the load from above essentially coming down in the middle of the span. I think that beam that I called out a W14 by 230 or something like that, sent over to the architect along with, hey, if we put these 2 columns in, this gets reduced a ton. He was as shocked as I was, and as you are, about the beam size. So, but there's been a couple projects where I've seen that things like that actually go through because they just are dead set on it, and the client has the pockets for it. But yeah, it's not. I wouldn't say that's a run of a mill beam for me though.
Okay. Because I'm saying, like, often in my mind, part of the separation between, dividing the structural world into residential and commercial is just like the significance of load. Like a house doesn't, weigh as much as concrete and steel usually do. So when you say a beam that size, it's like, man, you're pretty much doing a commercial building,
Four
because
parts of it.
yeah, because the whole detailing would start changing when you're dealing with loads that big, of how things go together. So
And
that was cool.
the tricky thing, I would say, like, it's less, the load is the load, and there obviously is load. But like you said, you're kind of just dealing with a, first floor, second floor roof in a single family house, and you're shedding some of it to the exterior walls, which is going down to the foundations. But a lot of times it's deflection driven, and I think that's something important to mention with these high end residential and whatnot. Most of the houses that I grew up in, that my friends grew up in, things like that, you could see slight cracks in the sheetrock, and maybe you spackle it every 8 to 10 years or something like that. We're trying to avoid that on a $60 million house. So we're really designing. Typically, I would say like L over 480 for a lot of the beams. But then as you jump up to 25, 30, 35-foot spans for some of these beams, L over 480 might still be, almost an inch or something like that. I don't know what the exact math is. But so then I kind of limit it to a half inch of deflection, because that's really where you're going to start to see, those sheetrock cracks and things like that. So sometimes I'm a little bit shocked at how low the end reactions are on a beam when it gets so high, but it's just because it's so deflection driven.
Yeah.
And in certain cases, there's very skilled steel fabricators out here, some very high end ones with great shops and things like that, that can achieve cambers and things like that. So we could camber the beam, put it in, and reduce the size, let it kind of settle on some of the dead loading and whatnot. There's also so many GCs, and there's a wide variety of GCs. So some are extremely high-end shops that are going to have 3 project managers on the job, making sure every detail is finally, followed. But there's also, it's a fine line of not trying to dumb everything down and not take any advantage of any kind of, nuances that you can do. But I also don't want to get too, you know, aspirational detail. It's like the shear walls. I never really show shear walls with nailing patterns at 4 inches on center, because either the contractor is not going to pick up on it and he's going to go with his standard 6 or 8 inches on center, and now that shear wall is going to be under, designed, or he's going to see it, say, this engineer is ridiculous. I'm not doing that, and we're still going to be under designed. So it's a fine line of trying to. A lot of times you can drill in epoxy, steel anchors into walls and whatnot. But once I'm starting to do moment frames and I need a fixed connection and things like that, I really, I try to put as many bells and whistles on my foundation plan to make sure they understand, cast this one in place. If this is the only one you do, make sure this is cast in place. So
like
it's
that the residential space touches on these like very commercial details and technical details, and then that's still detailed in the drawing sense, like into this wood frame house. It's just a real mix of, me framing a 2 by wall and the most complicated steel structure we can put together. It's like a fun
100%.
combination.
Yeah, yeah. And when you have a contractor who's, been doing it for 30 years, and he's been doing a lot of the conventional stuff, and he started to work up to 4,000 square foot spec homes that, are pushing some things, but then it gets to steel detailing or high loads, and you're able to avoid a steel moment frame by doing this ridiculously over designed shear wall with double-sided plywood and spacing at 4 inches on center. He's gonna be like, I've never done this in my life. I'm not doing this. So you try to balance that.
What about the loading? I'm just trying to think through this whole house in my head. These roofs might be super complex, and so maybe the trusses are massive. Or is most of the houses there stick framed? Are we talking they're steel with composite deck at all? With higher live loads for any reason? Vibrations, deflections. Or most of the houses in the Hamptons more steel or more wood, and then supplemented with steel as needed.
It's still a large majority wood. We're framing roofs out of 2x10s, 2x12s. Then in the roof specifically, If they want a cathedral roof, which a lot of these houses want vaulted ceilings, get the feeling of a larger room just in terms of that. So then you start having to frame out of structural ridges and valleys and hips and everything like that. And depending on the complexity of the geometry of the roof, that ridge might not be able to just be a standard ridge that posts down on the two exterior walls. It might have a reverse hip where, a lot of times we detail bent steel flitch beams, which for the listeners, a flitch beam is, I always describe it as an Oreo. It's two wood beams sandwiched with a steel plate in between. And then we get as large as 3 pieces of wood with 2 pieces of steel. You through bolt that, and you can really give some strength to wood beams. The biggest advantage of that, other than saving having to need steel columns, you can kind of post those down onto like PSL or LSL posts. But a large advantage of that is framers can install those. They'll order the plates, they'll order the LVL beams, engineered lumber. They can assemble the flitch beam on site, and then they can, however, they have a pulley system or something to get it up in place, but they don't necessarily need to have the steel fabricator on site to install that and install the through bolts and everything like that. So sometimes we weld those at the vertexes to have it chase down the roof line and get to an exterior wall. Obviously you have to check the moments at those vertexes and things like that. But I digress. We try to do as much wood as we possibly can, and it's kind of like I said, the roofs are kind of dimensional lumber. The floors, a lot of the times, most common is TGIs, which is basically like a wood I-beam with a plywood web and then a top and bottom cord. So that's when we can push 20, 21 feet with like an 11 7/8 TGI. So you don't need to get so tall to achieve some of these longer spans. And then as you're designing some of the main beams in the house, we try a flitch beam first after trying just an LVL. And then if needed, we jump up to steel when the deflection, just can't be met.
Okay. And then
those spans.
like code wise, what code are you or codes are you typically using to design these? I'm just so curious, and I know we're at a basic level right now, but
no, all good. Yeah. So I mean, ASC 7 is going to give you all the loading you need. Snow based on geography, wind, as we discussed, 130 to 140 miles per hour. Typically, the snow is kind of in like 25 to 30 pounds per square foot in New York, on Long Island. If you go upstate, it's probably going to be a bit more. Generally, live loading for residential habitable spaces is 40 PSF. The garages is tough. A lot of the garages are just slabs on grade, so you're just it's kind of a slab on grade. You're dealing with that. Oftentimes, they want to put a golf simulator or a gym or something down below the garage. So that's when you had mentioned composite decking. We'll do a lot of composite decking if we can span if it's a reasonably sized width of the garage, maybe you can clear span it, but a lot of the times we'll have to do kind of a steel grid system underneath it, span the Q deck across it, and then that's where you got to jump up to garage floor loading the uniform load, evaluating it with a 3,000 pound point load at the worst case scenario and things like that. So that's kind of the higher end things.
Are you using the IBC or the IRC for designing
these?
The IRC. Okay.
So in the commercial space, especially in steel structure, we often have our mechanical heating, air conditioning underneath the beams. We occasionally put big holes in the beams, but we avoid. How much of your attention goes into the mechanical space, and then also the detailing of thermal bridging at walls? Is that something that's a concern of the architects that you need to be a part of that conversation?
Yeah. So first, the mechanical, electrical, plumbing, things like that. I was fortunate enough, actually, very early in my career, the company I worked at previously was a smaller company. We were growing and whatnot. We had a main mechanical lead engineer who had been doing it for a long time, but she was starting to get overwhelmed. And I was starting to kind of, piece things together structurally, feel comfortable in it. So I actually started to learn duct sizing, equipment specifications, load calculations and volumes and things like that. So that has been a tremendous asset for me, and something that my clients are always extremely happy with when they finish up the structural and then they continue to deal with me on the mechanical. So certainly something that needs to be considered in residential, and a lot of times unfortunately isn't. And you get to the end, and then either the contractor's saying, we got to cut through this, we got to cut through that. But on some of the higher end jobs, the architects understand we need to spend some money, hiring a mechanical engineer to coordinate these things. So even if I'm not doing the mechanical, again, with kind of the collaboration up front and saying, let's do this because of that, I try to, provide value to the architects and clients that I'm working with. So I will try to have it in the back of my mind and be like, hey, what are you guys going to do? Are you going to soffit, one of these bedrooms, or do we have to do this instead of using TGIs, maybe using Triforce open web joists, so that they can, pass through some smaller duct things. But I have, and there's a mechanical engineers on the East End that will put together a full, duct layout and everything like that. And then whether we need to kind of create a channel for some of the main like a main trunk to go in, and then branch off with 4 to 6 inch rounds to feed some of the bedrooms, some of the steel penetrations, like you said. But I would say kind of in between that, some of the smaller houses, they just deal with it when they deal with it. The larger houses, we coordinate everything. Somewhere in between, a lot of architects will just plan on having kind of like, not your typical drop ceiling where it's the ceiling squares like you would in an office building or something like that, but they drop the ceiling, allow maybe 7 to 6 to 8 inches maybe of a plenum below the floor joists. And they'll do that out of like almost like a cold form steel dropped ceiling type thing, but they'll still hang their sheetrock or whatever kind of upper end finish they're going to do from that, which allows the mechanical engineer or just the mechanical subcontractor, when they come in and start running things kind of on their own, to live below the joist but above the ceiling.
What's your best save? A moment where a small structural tweak solved a huge architectural or owner problem.
So I would say, like, I try to get ahead of those things, like I kind of outlined before, upfront, trying to not back us into something where it becomes crazy and then I gotta, put on a cape and figure out something ridiculous to save the day. I think a lot of the times, like we had said, the architects can put together the framing plans and things like that, and sometimes they even do that. I won't name any names, but it is industry standard. They'll put together a set of plans and put together some general framing enough to get a permit and make sure the project's going to get off the ground. They don't want to start hiring all their consultants and having everyone run around, and then the town, especially in the Hamptons, there's architectural review board is a huge thing out here. So it might meet code, it might meet zoning and setbacks and things like that, but sometimes the architect's not confident if the house is going to 100% go through as is, so they don't want to start the structural engineer designing it, have to change this, pay a change order, things like that. So sometimes they put together framing that's in the right ballpark, but they still want to get me on once they get permit and, okay, we're getting ready for construction, make sure this all stands up correctly. So on a lot of times with that, or with renovations where they call me on after they start to kind of gut reno everything, especially some of these historic renovations that are very old houses, either the architect is kind of looking at it, and I think everyone, you kind of get tunnel vision. You think about it one way and you start just driving, how do I make this work? How do I make this work? There's been times both looking at architects' framing plans where it's just like, well, we could just do a bent flitch beam. And they're like, what do you mean by a bent flitch beam? Like, I thought we had to frame this thing out with 6 different beams and get it all the way over to there. And I'm like, no, we can design something that's going to come down and, span over there. So, I think some of those things where it's, bringing that higher end kind of, Max, like you were saying, with like bringing kind of that commercial thought, a little bit higher end structural engineering to residential. People are thinking like, how do I just do this with a couple 2x10s and this and that? And it's like, well, if we do something a little bit more, I guess for lack of a better word, cutting edge, then we can alleviate a ton of these issues and, deal with the load that way. So
yeah, I mean, you're just reminding the architect, like, there are other tools to solve this problem. And it doesn't need to be some very complex thing like we can do this style. But
exactly. And I think like you said, complex, but like they're trying to use conventional tools. And then if we use one complex, tool, we can make the entire problem so much simpler.
This episode is brought to you by CalcBook.
As engineers, we all want calculations we can trust. But spreadsheets are cumbersome, with traditional tools often feel like clunky black boxes, slow, outdated, and impossible to verify.
CalcBook is different. It's modern, intuitive, delivers professional hand-calc style outputs that give engineers real confidence in the design.
Listeners of the Structural Engineering Podcast get 50% off their first 3 months. Just visit calcbook.com. Use promo code SEPOD. That's SEPOD.
Calcbook, built by engineers for engineers.
Is there a common surprise kind of thing that catches you midstream designing structural, or maybe a project change that you didn't really expect but happened more than you wanted to?
I would say, you have to know the game that you're playing. Being in, again, high-end residential, custom homes, you're going to have an architect, you're going to have an interior designer come in once they're starting to get ready to do finishes, and they're going to want to take out a wall last minute that, is a major structural wall that hides one of your, ridge beam posts. So, it not more often than not, but a lot of times, you kind of work through an entire design. They're gearing up for construction, and then the architect or the homeowner or the interior designer will reach out and be like, "Oh no, Sean, we need you to update this, and we're starting to dig in 2 weeks. We removed that second floor bedroom wall, and it's like, okay, well, we got to address this quickly. Obviously, you have to charge for your time and things like that, but uh, it's how do we address this quickly? But especially those upper floor things, you got to redesign the roof framing, trace that load down, adjust all your calculations. Even if the load moves 5 feet this way because they move the wall 5 feet, you got to check that beam, redistribute the reactions. Now, most of the loads going to this beam that's clear spanning the living room rather than falling nicely into this wall below. So I would say that's kind of the nature of residential. The homeowner and the architect on a daily basis are re-envisioning their artwork and their dream home. So it's par for the course to have some last minute changes.
I was talking to a residential engineer the other day and asked him a couple of these questions in preparation for this episode. And he was telling me quite often he will design the architecture of the house as well as the structure. He said, maybe half the projects an architect's involved, the other half I'm kind of laying things out for him. I can follow the code for restrooms and dimensional spacing requirements, and maybe I might ask a designer for a little help on the exterior here or there, but it was more driven by the structural engineer. Do you see that at all out there?
So going back to the architects can design structure, similarly, the structural engineer can design architecture. At the end of the day, the building department wants a design professional, quote unquote, to put their stamp on the set of drawings architecturally, structurally, whatever is needed. So I have done, actually at my previous firm, I had done a couple higher end architectural jobs that the owner and the builder, it was kind of repeat clients, and they were like, listen, can we just work with you guys to figure out what we want to do? It's an investment property. It's not, we're not looking this to be detailed to the nth degree of, some of these higher end architectural firms that really every single, piece of trim work's detailed and things like that, which you need on some of these elaborate homes. On my own, I've done a couple small, if someone's doing a renovation and they want to blow out their kitchen wall and do a 7-foot extension, I could draw the existing conditions and extend that, rectangle out, and then move right into structural, size them the beam that they need to pick up that second floor above and pick up the shed roof that's coming off. What I always say is whenever someone, even at my old firm, when I was the lead structural engineer at my old firm, so I was involved with a lot of these, proposals and things like that up front. Something I would always preface is I'm an engineer. I see things as black and white, very binary, ones and zeros. So I can draw you a rectangle that says bathroom and your kitchen here and this and that, but don't ask me for inspiration. I've seen I've been around enough high-end residential, but it's kind of like on the architectural side, I'll put together a set of floor plans, a section, your exterior elevations, the notes you need for permit, but I don't really care if that window is square or has a curve to the top of it. So
I have a quick expansion on the last question that we were talking about. Is there any residential detail that is often that the owner or detailer owner or designer might see as like this minor thing, but it's actually carries a lot of structural weight, stacking a column, or is there anything that's just never stands out as that's going to be a lot more than you think?
So two things come to mind. One is a little bit smaller of a thing, but is so much easier to deal with during the initial, just laying out of beams and things like that, is curbless showers. A lot of the times, in my house at home, I have a curb around the shower so that water doesn't get out. The solution to that, to not have to step into your shower, is to depress the framing. So if you're using 11 and 7/8 inch TGIs everywhere, you might want to jump down to 2x8s or 2x10s in that area. Um, so it's normally not like a structural, you know, this huge structural gymnastics to do. But once you trace all the load and then you got to put in a couple beams and header it off and things like that, it's a little difficult. So that's one thing that if it's not planned up front and then at the end they're like, oh, we wanted to do curbless showers on all the bathrooms, it's like, okay, I do have to run a decent more calculations than just say 2x8s. Ta-da. That's one thing. And again, we normally just frame that out with 4 beams, and then inside of that you infill with the 2x8s or the 2x10s, and you trace the load accordingly. The bigger thing, especially on modern homes and on homes that don't have that 6 to 8-inch mechanical plenum, when the ceiling is tight up against the floor joists, a lot of houses, especially the modern houses, but I would say a decent amount of houses in general, want to do shade pockets so that they can have a retractable solar shade come down, and it's tight. It's basically recessed into the ceiling, and it comes down tight with the windows so that you could either, typically it's kind of 2 rollers. One is a very thin roller that can come down and just provide basically privacy, especially for houses on the beach. When it's a public beach and people are walking by, you don't want people looking in. The other is actually on really hot days when the house is starting to heat up, you can put down the solar shades and really save a ton of your air conditioning from getting out the windows. So the issue with that, when there's no mechanical plenum, is, especially with TGIs, you can't notch out the bottom chord of a TGI. So what we really need to do is box those out in a similar fashion to kind of the curbless shower, but you almost do like a double header condition, and the shade pocket lives between those double headers. Where it gets really complex, one, contractors typically don't love to see a huge beam just inside of a small header, because that header on the outside sometimes is only taking the floor above, and if that's a load bearing wall, depending on how much load it's taking, but typically that one's not doing too much work, but then you have a pretty decent beam on the inside. So that's normally wonky for a contractor to see, and they question it, and then you got to kind of explain why we're doing this. The even step up from that is when you have multiple corners of shade pockets coming together. Basically, that inside header wants to go to that perpendicular wall and frame down onto that, or frame into a beam that crosses. But if you have a corner of a continuous shade pocket, then what we typically do is we frame it out of steel, and then you notch out the bottom flange so that you can kind of go up and over the adjacent shade pocket. Hope I'm connecting the dots reasonably well there.
Yeah.
So that's one thing, and sometimes that's not that's kind of, hey, here's the house, can you start designing? We do everything, and then it's like, oh, we have shade pockets everywhere, and it's like that really changes everything. So definitely, with experience, when you see a house that looks like that caliber, I try to ask some of those questions up front: curbless showers, shade pockets. What are you looking to do? A lot of the second floor decks that they want to cantilever actually also needs to get shallower so that you can basically put on some kind of pitchboard, waterproofing membrane, and still shed the water away from the house. If that happens on top of framing that is the same depth as the inside of the house, then you start to build up with sleepers, pitchboard, this, that. Now, when you step out of your slider, you're going to have a little bit of a curb there, which you don't want. So you got to, make sure that you and the architect are aligned on your waterproofing. Well, basically their waterproofing, and let's make sure we provide the small enough structure to allow for that,
Right. What about anyone doing a rooftop pool on these houses?
I don't know if I've done a rooftop pool. I know one of the engineers in my department a few years ago that I was overseeing had a helicopter pad. So that was a tremendous amount of coordination between her and they had to get basically the person who was going to put in the helicopter pad and give us some lateral thrust to account for and things like that.
Yeah.
I have not seen that built. I don't really know where that plan ended up going. Most of the houses we do get built, but sometimes you design something and you don't hear about it and then you might hear about it for 4 years later, and they're like, "We're revisiting this." But I I don't know how well, I mean, she over designed it quite a bit with the thrust and things like that, but I'm sure vibrations and things like that, you're gonna feel that helicopter on a, wood framed house.
Yeah.
Um, but
So you brought up a little bit about contractors. For a lot of these houses, is it mostly design and then bid and then built, or is it a contractor's on board early? Do they help with the conversation of constructability and costs? I mean, what does that process look like? If are you getting into VE during design, or is it once a contractor is brought on?
typically it's let's design the plan, send it out to bid, get, the most competitive pricing, and then okay, the most competitive pricing was still a little too high, let's VE it. There's been a number of jobs that we've had kind of a contractor on as, consultant, which I always love because I always do try to give feedback on both pricing but also constructability of like, hey, this is key example. I would say like a month ago, I was working on a pretty decent renovation. They're doing an addition off the front of the house. They wanted to change the flat roof into a pitched roof, so we were adding some dead weight. So what they came to me with, we're doing this small renovation and we're doing a couple bump outs for some additions and things like that, but we want to pitch this, do a pitched roof on top of the flat roof, basically just build a deck on top of there for aesthetics. But once we add dead weight, I have to evaluate the existing structure that's holding it. It kind of became like, guys, everything in this house is underdesigned. We need to reinforce or replace. And then it kind of boiled down to like the ceiling over the kitchen was like the one thing we were trying to maintain. And I was like, it was a pivot in the road. I laid out a ton of stuff and started to realize how much needed to be redone or reinforced. And I said, listen, I can continue with my design of trying to do this surgically and whatnot, but I don't think that's the client's, let's jump on a call with the client. Me and the architect explain to the client, it might make sense to we can save the foundation, but really just rebuild up instead of trying to save this and that and reinforce in there and this and that. They ask me what's the cost difference, and I'm like, I don't actually price this stuff, but I have a general sense of what the contractors are going to prefer. It's probably going to be very similar, more of a headache to temporarily support the walls and this and that, but I have to talk pretty vaguely. So when there is a contractor on board, I can explain my thought process, explain what beams need to be redesigned, and then you're gonna have to temporarily support that wall while you try to upset that beam and this and that. And then I can be like, don't you agree or whatever? And then, the contractor can, be like, oh yeah, no, there's no point in me building those temporary walls. That's gonna take me 2 weeks to just temporary support. Then we're gonna do the work and this and that. We could be through that kitchen reframed in a day. So that's what happened on that renovation was they ended up calling a contractor they knew, he agreed, and then now we're going to pivot to just, hey, let's, redesign this. So I always do prefer that, but it's seldomly, they want to get the most competitive pricing. So they don't want to give someone the job before it's even designed and priced.
Yeah. I feel so often that like the owner and the architect will hear us as structural engineers saying, this is going to be expensive and these are going to be really challenging to build. And they go, yeah, okay, sure. And then once the contractor shows up and they say, this is going to be really expensive, let's not do this. They go, oh yeah, of course. And you're like, what the heck? I told you this like 2 months ago.
Yeah. Well, and that's because they can put the two bills in front of them and say,
bingo,
50,000 versus 150,000. I can be like, it's going to be a lot more, but exactly what that's going to be, I can, exactly tell you.
So you were talking about reusing foundations and stuff. Pretty good soils out there, deep, shallow. What are you guys dealing with?
It's I wouldn't say 50-50. I would say about 70-30. Pretty decent bearing capacities, a lot of the inland areas. We do have a pretty decent amount of ponds. Georgia Pond comes to mind specifically whenever, and that's a nice like estate area, so that's why it's familiar to me. Whenever there's something on Georgia Pond, it's inland. People kind of like expect you don't need to do piles because you're not on the ocean. But around that area is not so good. But we always do, especially, if it's a small renovation or something like that, or we've done, I've done work in that specific area down the road, which, there's only so much room on the East End. You're in the general vicinity. I would say on 80 to 90% of projects, we use a subcontractor that does standard penetration testing. So we'll get them on to do 2 to 3 holes, and then we can really, determine the bearing capacity, depth of the groundwater, things like that. But yeah, certainly the beachfront houses, typically we either need to go with timber piles or helical. The contractor's normally trying to push for timber, but because it's a little bit cheaper, but the helical, the non-disruptive nature of that with a neighbor to the right, a neighbor to the left, and normally a neighbor to the right and a neighbor to the left with an all glass house. I don't really want to be on the team that's driving piles, 200 feet from that house. So, and then I tell them do ground vibration monitoring, and they say, yeah, we'll do it. And I doubt they do, but.
So a lot of our listeners are younger engineers, either in college or in their first few years outside of college. What would you say is one piece of advice you would give to an engineer that is either new to the residential world or is looking to get into it or looking to move from the commercial world into residential?
So in terms of preparing, if you know that you want to get into residential and whatnot, and you have the time, the time horizon for it, I would say one of my biggest benefits and one of the biggest benefits I've seen from structural engineers who are doing residential construction is actually, either growing up or working at some point in your life as a framer and being on the job site and understanding, it's the same as the commercial world. It looks good on paper, it looks good on computer, but then it's how do I fit the wrench in there and do this and do that? But, and that kind of blends into what I'm going to say about someone going from commercial world to residential, as I think with any sector. If you get into designing hospitals, there's going to be the nuances there. But something I've seen a lot with people who have made that transition is, you might have a good solution, but there's, I think even more so potentially in residential world is like, no, we just want to do it this way because it's the cheapest way to, frame it out of wood instead of, yeah, what you presented works, but they're just going to do it this way. And that was, during my learning curve early in my career, I would try to, go to my bosses with, 2 to 3 options of like, hey, I'm thinking this, but it seems like it's getting a little ridiculous. I'm thinking that, and or maybe I'm even thinking a third thing. And a lot of times it'd be like, those all work. It makes sense. It's good logic, but they're just going to do it like this. And it's like, oh, that's going to be so much easier. Like, because there's just maybe a Simpson hardware that does what you want to do, or, things like that. I can't point to exact examples, but it's very nuanced in that sense because you are continuously jumping between wood and steel and what makes the most sense and what's going to be the cheapest. You don't want to just we could design every house to just have all steel and none of them are going to get built because they're going to be over budget.
Is there any questions or anything that we haven't talked about that you think would be really interesting to make sure that our listeners know about?
I mean, I would just point to kind of back to like the differences in like a small typical residential house versus a high-end house. The amount of complexities, and I think you mentioned it earlier as well, is the challenge to not just defer to costs all the time. I think a lot of the times on commercial jobs, it comes down to the bottom line and, oh yeah, throw that column in there. Like this isn't, you really get tested on your understanding and, kind of problem solving. When you say, we can't do that, it's, well, what do you mean we can't do that? Like I've seen crazier things done, and that's why I kind of always say there probably is a solution. We've done things where you've done columns in tension to hold up a beam because you have a wall above and you don't have a wall below, and you got to transfer that load other ways. And that's like, it's really getting out of the box with residential, especially high-end residential. So I think that's the fun challenge. I always joke as well. I sit on the computer and I design a roof, I design a second floor, design a first floor, design the foundation. And then sometimes it's like, oh man, I'm finally done with that project. But all I'm doing is going to go and start on another roof on another house. But because it's such a different house, and this one's modern on the beach, and this one, is a, like I said, old school West Hampton type house that has gambrels with a reverse dormer coming into it, and then like it just feels new. And it's it's always cool to see the renderings up front, and it's like, oh wow, this is going to be a real profile, portfolio project. This is going to be beautiful when it's built. And that's going back to my dad starting the pool company. When I worked for him, there was the service, which was cleaning pools, which was the way easier job. It was just take your list of pools, go skim the top of it, test the chems and everything like that. But I was always frustrated when I had a work service, and my dad would be like, you're working construction, you're jackhammering, you guys are doing a renovation of this pool. You'd rather be doing that than just going and, skimming the top of a pool for some leaves. But it was the reward at the end. And I feel in a similar fashion, the late nights, the frustration of the, time crunch, the last minute change, this, that, when you get to go stop by the house or you drive past the house when it's completely minted out, and the reward, especially, again, back to the first question, you're not on a team of 200, 20 other people or whatever. Most of the time it's you designing every beam in that house, and you see it standing up and you're like, wow, so that's, I feel like, where I get my reward from for what I do.
I think that's a great way to wrap up the episode. So Sean, thank you so much for being on the podcast today and talking to us as well as our listeners about residential engineering.
Absolutely. I really appreciate you guys having me.
One last thing before you head out. Structure Ed. We've been trying for several months to build a study app for all the tests we have to take. Our weekly trivia helps make some of those questions, so they're connected, but we use some AI to help define the rules based on the 100 or so we made to make 1,000 more. We're up to 1,500 questions at this point. If you're still listening, you probably like engineering, so if you can help us make this free resource, that would be amazing. Questions can be submitted on the website. I have to click to approve just so we don't have weird spam stuff, and then everyone gets to learn from your knowledge. Everyone gets better. If you've been on the site before, we had a rocky start, but I think things are finally looking good. Hop on and check it out. Honestly, if it isn't good, please email me and suggest an improvement. I bet all the practicing structural engineers can make an extremely good free study tool. So let's do it. All right, see you in 2 weeks.